All right, so good afternoon, everyone. Hello.
Good afternoon,
Good
sir.
afternoon, sir.
Okay, so for today's meeting won't take that long. Okay, so most of you have already seen this one, maybe. Okay, so this is your week two topic. So we have Power DC and series parallel network and Kirchhoff's loss. So basically, the first one that we'll discuss for now is the power in DC. Okay, and then the next meeting, which will be on this coming Saturday, will be the series parallel network and Kirchhoff's loss. All right, so for your lab number three, so this is of course the instruction. Okay, so just click this one and then you will see this lab number three. So please download this one now so that you can have your own copy. And this is where you can also put your answers. Okay, so for your lab number three, this one is super easy. Okay, so I'm really hoping that you guys really understood this one without without uh, my help. Okay, because I was actually planning to just to give this one to you and let you guys do whatever I'm asking you to do it right here, like procedure one, two, three, and one to four only actually. One to five. Okay, and then the last one is just a conclusion. Okay. So once you've learned the basics when it comes to Ohm's laws, powers, heat, etc. Okay, so this one is already super easy. Okay. So yeah, the objectives of your lab number three is to understand the definition and functions of electrical power and to learn how to measure the power dissipated in a DC circuit with the use of LT-Spice. Okay. So yeah, of course we're going to use the application and then here's the discussion and here are the formulas wherein you can get the power. So we have the voltage, the current, I squared times the resistance, E squared divided by the resistance. So all of those, you can use any of those to get the power if you're going to solve it manually, okay? But of course, if you're going to use the LT-Spice, so you don't need those things anymore. So yeah, and for the procedures, so those are super easy. So I will leave those uh, procedures to you. And if ever you guys have a question in future, so just let me know. Okay, just ask a question. Though I doubt that you're going to have a problem since this one is very straightforward and very easy. So what else? And please to visit this one also. So this is very important. In every week or in every module, okay, we have this overview. So just click this point first, okay, before going or diving into answering this lab number three. Okay. So this is where I put some videos or some reading materials which will help you to answer the laboratories much more easier or much more quicker. Like for example, this one, we have this video materials which I included. So this is a 1 minute video, okay, which will teach you on how to measure a voltage, a current, or a power distribution on this particular circuit. Okay, so I don't really use this kind of method, but this is very helpful if you want to have a quick peek. Okay, you want to have a quick peek on the results of this path or this node or this resistor or any component. Okay, so I just would like to show this one to you guys that he has a circuit and then he ran it. Okay, fast forward, fast forward. And as you guys can see right here, upon hovering, okay, hovering the mouse right here on this node, it will give you this node or this, can you guys see this one? The information on the bottom left, one that has an arrow.
Yes, sir.
Okay, so this is already showing all of the information that you're needing. Okay, like for example, this one is node N002, though this one is super small, but this one is node N002, and then DC operating point VN002. So the name of this node is VN002, wherein it has a reading of 7.09 something volts. Okay, so it's a long decimal. And so wait, and if you also pinpoint it onto the another node, it will give you also another node of name, which has a measurement of 5.077. Okay, so as you guys can see, without even using the graph or without even using the probe, just by double clicking this one to get the exact reading on this node or on this resistor, you will see it right here, by the way. Okay, and this one is an indicator that this one is a ground. Okay, etc., etc. So my point here is, you can also do this one. Yeah, you can also do this one, but the one that I'm asking is the screenshot. The screenshot of your graph. So measure the current of the circuit and take a screenshot of the result. Okay, so I need the screenshot of the graph itself. Okay, though you can check it on the bottom left, but that's just a quick peek or a quick guide, okay, on what is the name of that node and what is the value or the current on that node, etc., etc. Okay, so even though you have that function on the AltiSpice, I still need the graph. Okay, so put here the graph down below, and then the computation, etc., etc. And then does all of your values agree? So yes or no, if all of them agrees or no. And then just a short discussion, okay, or a short conclusion or opinion from what you have learned from 1 to 5. So the reason why this one is super simple, because I just would like you guys to see the computation that you will get manually, and then the computation that you will get if you're going to use AltiSpice. So you can come up with a complicated circuit, but of course you have to solve that one also via manually. So that is why I created a super simple schematic for you to calculate it as soon as possible. Okay. So my point in here is just to prove that this AltiSpice is really working in terms of those formulas. Okay, like those two will give you the same answer. Okay, so yeah, that's it for your lab number 3. And the next meeting, you're going to have your lab number 4, okay, which deals with Kirchhoff's law. And then another thing, oops, accidentally close everything. Okay, so just wait a second. And then oops, not this one. This is your lecture. And then I've also prepared a practice or exercise, which is a link which will lead you to another website. So just check those trails. Although those are just the basics, just in case you don't know what is power yet, like you're completely clueless about what is power and how it is being solved. So you can visit those 3 sites, just to learn more about power. Okay, and we have here the case study. So this is your second case study for the laboratory. So in here, we have the facts about the power. So what is power, and then definition of the power, and then the question. So now that you've learned this definition, usage, and importance of power in the world of electricals, okay, in your own opinion, as a human being, what do you think is the main contribution of power in our environment? Okay, like what is the role of power in our society? Okay, and just think about what are these advantages and disadvantages if we don't have this research about power. Okay, like basically, yes, we have voltage, we have current, and then we have the resistance, and what is the main contribution of power? Okay. Why do we need power in our society? All right. So yeah, that's it for the case study 2. Okay, let me just edit this one. Case study 2. So the deadline of this one will be on March 10, I guess. So let's check March 10. So it's always 1 week. Yeah, March 10. So you guys have 1 week to give your own opinion. Right? So, any questions so far regarding with your love number 3? So this one
None,
is,
sir.
Meron po.
yes?
Sorry, LT Spice lang po ba yung pwedeng gamiting application, sir? Or pwede rin pong gumamit ng example po is multi-SIM.
Yan?
Multi-SIM, sir.
Yes, it's possible also. Though I'll be having a hard time in checking that one since I'm not that familiar with the other applications that they are using when it comes to simulating circuit. So it's possible, okay lang din, as long as mapakita mo.
Okay po. Thank you, sir.
So if you guys are going to use another application, so please let me know so that I can have quick try this one, quick pick, okay, that application that you're going to use. All right, and yeah, I guess that's it. So any other questions or clarifications? Oh, I forgot. Okay. So one reason why we've had a meeting for today is to show you guys this is just a quick example. All right, so what I would like you guys to do is, let's say you already have your circuit, right? Like for example, this one, a parallel circuit. So to measure the power, so just hold your Alt button on your keyboard, Alt, and it will give you like, this thermometer temperature icon, sure. And yeah, so in this case, you'll be able to measure the individual power that is being dissipated on this specific resistor. Like in here, it is dissipating 6.4, okay, 6.5 rather, 6.5 milliwatts. Okay, and then more. So you can do that on all of your components. Of course, it will give you 3 individual lines, right? So as you guys can see, this one is also the formula of our power. Power times the resistor, okay, times I squared. Is it I squared? N002, N001. IV. No. So P is equal to IV, okay, not I squared. Okay. So the current and then but we have the resistance. I am now confused. So Vn003 N0, which is the voltage times the current. So sorry, this is the PIV. Okay, the one that is getting in here is the individual current and then the individual voltages across through that component, right? So yeah, that's how you measure a power. Okay, just hold your Alt button and then just left click that part. All right, so yeah, any questions so far? No? Any question or clarifications?
Wala naman, sir. Wala
None,
po,
sir.
sir.
Okay, and one last thing, the reason why we've had the meeting for today is this is like a consultation day from the topics that we have last meeting, like your lab 1 and lab 2. So have you guys encountered the problem? Is there anyone here who's having a problem or encountered anything on doing the lab 1 and lab 2? So I guess none. So lab 1, you don't need LT-Spice. Lab 2, you need LT-Spice. So is there anyone here who doesn't have an LT-Spice application yet? Because if you still don't have an LT-Spice, then you have to hurry and install it now so that you can do the following laboratories, lab number 2 and lab number 3. All right. So if you guys do not have a question anymore, so again, thank you guys for coming. So that's it. You guys may have a blessed afternoon. And see you guys on lecture. Sa mga may lecture. Yung mga iba siguro wala.
Thank you, sir.
Thank you,
Thank
sir.
you for coming.
Thank you, sir.
Thank you po, sir.
Yes, sir.
Bye-bye. So just message me as soon as you have a problem, okay?
Yes, sir.
All right. Okay then. So see you guys on lecture. Goodbye.
See you, sir.
Bye,
Bye,
sir.
Bye-bye.